Picture this. A time traveler stands in a dimly lit room, clutching a pocket watch. Its gears are intricate, its craftsmanship flawless, a relic from the future. The traveler steps into a time machine, hurtling back to a moment decades before their birth. They leave the watch in a hidden compartment, then return to their own time. Years later, they discover the watch in that very compartment, its origins a mystery. It is the same watch they now hold. How did it come to exist? This is the bootstrap paradox, a scenario where an object or piece of information exists without an origin, perpetually trapped in a loop of cause and effect. It defies our linear understanding of time, where every event has a beginning and an end. Instead, it suggests that some things are self-caused, and their existence is sustained by their future. The paradox is named after the bootstrap theory in physics, which posits that particles can exist in a self-sustaining loop without an external cause. The paradox is named after the fictional trope of pulling oneself up by one's bootstraps, a metaphor for achieving something impossible through self-reliance. In the bootstrap paradox, the impossible is the creation of something from nothing, or rather, from itself. The paradox is unsettling because it undermines the very foundations of causality. If an object can bootstrap its existence, what does that mean for our understanding of time, reality, and free will? This concept is not just a thought experiment. It permeates science fiction, philosophy, and even quantum physics. Consider the movie 12 Monkeys, where a character's memories of the future become the blueprint for a catastrophic event he later witnesses. Or the Doctor Who episode where a guitar's existence loops through time, its music both creating and being created by the Doctor's actions. These narratives mirror our existential questions. Are we the authors of our destiny, or are we merely participants in a script written by our future selves? At its core, the bootstrap paradox is a challenge to the principle of causality, the idea that every effect has a prior cause. In the paradox, an object or piece of information becomes its cause. The watch in our earlier example is both the effect, the traveler finds it in the past, and the cause, the traveler brings it to the future. There is no first instance of the watch. It is eternal, sustained by the loop itself. Philosophers and physicists have long grappled with this idea. In 1951, mathematician John Wheeler proposed a thought experiment involving a self-creating universe. Imagine a wormhole that travels through time, creating a loop where the wormhole's existence is both the cause and the effect of its creation. This is the essence of the bootstrap paradox, a self-contained system where the beginning and end are the same. The paradox is not limited to physical objects. Information can also bootstrap itself. Consider the time loop trope in movies like Groundhog Day, where a character relives the same day repeatedly. Each iteration adds knowledge, but that knowledge is only possible because of the loop itself. The protagonist's memories of future days exist because they experience them in the loop, a paradox of self-referential knowledge. To understand this, let's dissect a classic example. A scientist invents a time machine in 2050. They send a blueprint of the machine back to 2020. In 2020, their younger self receives the blueprint and builds the machine. The scientist then uses it to send the blueprint back in time. Where did the blueprint originate? It was never created. It simply exists, sustained by the loop. This scenario is mathematically similar to a Mobius strip, a loop with only one surface and one edge. Just as a traveler on a Mobius strip can traverse its entire surface without crossing an edge, the bootstrap loop contains its beginning and end. The paradox gains further complexity when applied to living systems. Suppose a time traveler sends a seed from a genetically modified plant to the past. The plant grows, evolves, and becomes the ancestor of the very plant the traveler took the seed from. The plant's existence is a closed loop, with no original source. This raises questions about evolution itself. Is life a bootstrap process, where future adaptations influence past evolution? The bootstrap paradox forces us to confront profound questions about reality, free will, and the nature of existence. 1. The illusion of causality. If bootstrap loops are possible, causality becomes a circular concept. Events are not strung together in a linear chain but exist in a self-sustaining web. This challenges the idea that we can predict or control outcomes. In a bootstrap universe, the future is not a blank slate. It is already written, and our actions merely perpetuate the script. 2. The death of free will. If every action is part of a pre-existing loop, free will becomes an illusion. The time traveler in our example cannot choose to destroy the watch, because doing so would break the loop and erase its existence. Their choices are constrained by the loop's necessity. This echoes the philosophical debate between determinism and free will. If the universe is a closed causal system, are we merely actors in a play written by the laws of physics? 3. The nature of time. The paradox suggests that time might not be linear. Instead, it could be a dimension where past, present, and future coexist as a block universe, as proposed by some interpretations of general relativity. In this view, the bootstrap paradox is not a contradiction but a natural consequence of time's multidimensionality. 4. The origin of information. If information can bootstrap itself, where does knowledge come from? Consider mathematics. Could a theorem exist without a discoverer? In a bootstrap scenario, mathematical truths might be eternal, existing in a Platonic realm outside of time. This idea is central to the Platonic realism philosophy, which argues that abstract concepts have independent existence. 5. The ethics of time travel. Bootstrap paradoxes complicate ethical frameworks. If an object's existence is guaranteed by its future self, is it morally permissible to alter its timeline? For instance, if a time traveler sends a vaccine back in time to prevent a pandemic, but the vaccine's existence depends on the pandemic occurring, is their action ethical? They save lives but also ensure the pandemic happens. 6. The limits of human understanding. The paradox highlights the boundaries of human cognition. Our brains evolved to perceive time linearly. We struggle to grasp nonlinear causality. This limitation raises questions about whether reality is fundamentally beyond our comprehension. Perhaps the bootstrap paradox is not a flaw in our theories, but a clue that our understanding is incomplete. 7. Quantum mechanics and entanglement. In quantum physics, particles can become entangled, sharing states across time and space. Some theories suggest that quantum systems might exhibit bootstrap-like behavior. For example, the delayed choice experiment shows that the past behavior of a particle can be influenced by a future measurement, a quantum bootstrap. 8. The paradox of the first cause. The bootstrap paradox challenges the philosophical argument for a first cause, e.g., a creator or prime mover. If causes can be self-sustaining, perhaps the universe itself is a bootstrap system, needing no external origin. This idea is explored in the cosmological bootstrap hypothesis, which posits that the universe's beginning is its cause. 9. Art and creativity. Bootstrap paradoxes mirror the creative process. An artist's inspiration might come from a future version of themselves, creating a loop where the work is both the cause and effect of its creation. This blurs the line between creator and creation, suggesting that art is a dialogue across time. 10. The comfort of loops. Despite its unsettling nature, the paradox offers a strange comfort. If existence is a closed loop, there is no ultimate beginning or end, only continuity. This aligns with Eastern philosophies like Buddhism, which view reality as an endless cycle of birth, death, and rebirth. The bootstrap paradox asks, can cause and effect collapse into a loop? The grandfather paradox, however, asks the opposite. What happens when we try to break that loop? Imagine the time traveler in our earlier example decides not to preserve the watch's loop. Instead, they destroy it in the past. Now, the watch never existed in the future, so the traveler could never have brought it back. This creates a contradiction, a paradox of impossibility. The grandfather paradox explores the consequences of altering the past, not sustaining it. It is a paradox of erasure rather than creation. Where the bootstrap paradox suggests a universe of self-contained loops, the grandfather paradox hints at a reality that enforces consistency, erasing contradictions through parallel universes or timelines. Both paradoxes are two sides of the same coin. One celebrates the possibility of eternal loops, the other confronts the impossibility of breaking them. Together, They frame time as a concept that is both malleable and rigid, a dance between freedom and constraint. As we turn to the grandfather paradox, we will explore what happens when we try to defy the bootstrap's self-sustaining logic. Does the universe allow such defiance, or does it punish us with existential contradictions? Let us drift into the next segment, where the delicate fabric of time is torn, and the consequences are anything but simple. This expansion delves into the bootstrap paradox's philosophical, scientific, and narrative implications, maintaining a reflective tone while avoiding bullet points. The transition bridges seamlessly to the grandfather paradox by contrasting loops of creation with loops of contradiction.